going to use some Euler's method and slope fields. So slope fields, it looks terrifying, but it's actually quite easy. We have this equation right here. dy dx, so the derivative is x plus y. So let's see, x plus y here is -3, and -2, and -1, and 0, and -2. Feel free to pause and do it yourself, or do it ahead of me, whatever makes you happy. If you haven't figured it out yet, hopefully you will. And I did it. So now I take those and I go over to the right here, and it says draw them. So at -2, -1, the slope is -3. So I'll approximate that like that. At -2, 0, the slope is -2. So let's make it a slight bit shallower. And at -2, 1, it's -1. And then at -2, 2, it's at 0. And at -1, 2, it's at 1. At -1, 1, it's at 0. At -1, 0, it's at -1. At -1, -1, it's at -2. Do you get the point? So we have a slope of -1, we have a slope of 0, we have a slope of 1, we have a slope of 2, we have a slope of 3, of 2, of 1, of 0, and then 2, -1 is a slope of 1, and then a slope of 2, and then a slope of 3, and then a slope of 4. Don't worry too much about the steepness. You have to have the right idea. That's all we're doing with slope fields for that. Now, if you're wondering what the heck are we doing, if you imagine that there's initial conditions, say I had to go through this point right here. Well, what would happen is as we go this way, we'd follow the slope field, and as we go this way, we'd follow the slope field. So we do something like that. Now I'm going to go ahead and let you play with these ideas. Feel free to pause the video and think about this for a moment. Did you pause it? I hope you did. So I'm going to go ahead and try to do these relatively quickly. So when x is 1, the slope is 2. When x is 2, the slope is 3. And when x is 3, the slope is 4. When x is 0, the slope is 1. When x is -1, the slope is 0. When x is -2, the slope is -1. And then -2. Something like that. When y is 0, the slope is 0. When y is 1, the slope is 2. And then the slope is 4. And then the slope is -2. And then -4. When, x plus y is what we're doing with. So when x and y are opposites, our slope is 0. So I'm going to suppose that they're opposites. And then at like 1, 0, 1, 0, the slope will be 1. 0, 1, the slope will be 1. -1, 2, the slope, okay, so like we'll go diagonally here. And then, so that was 1, and then I bet the slope is 2. And then 3, and then 4, and then 5. And then at -1, 0, slope is -1. So we have a pattern along the diagonal. -2, I missed that point, it's okay. -3, -4, and -5. 2x, so when x is 0, the slope is 0. When x is 1, the slope is 2. 4, 6, -2, -4, -6. Don't worry too much about steepness, just have the idea. I'm not going to do this part. I believe you can figure it out. Ooh, now we got to match things up. Okay. Match each slope field with the equation the slope field could represent. So what this means, this is not the derivative. Sorry, this is not the equation. So like y equals 1, you might think is, say, number 10. But that's not quite right. That's like the antiderivative, because the slope field represents that. So if I have, say, like this curve here, looks something like that. So the slope is 0 at 1. Well, that's going to be the cosine, because the derivative of the cosine is the sine, and the slope of that is 0. Or the value of that, sorry, is 0. So this is like y equals 1. And sure, that could be a. And then this looks like y equals x of some sort. And let's see, what do we got here? We got some sort of swoopy here. We've got something that maybe looks like this. Maybe that's like a quadratic, so x squared, so c. And this looks something like this. And I'm going to say that 11 looks kind of like the natural log of the absolute value. And then I'm going to say this one looks something like this. So that looks a lot like 1 over x squared. Alright, so same idea, but this time, this is differential equations. So let's see. I'm going to start with, I feel like c is the easiest one. So c is dy dx equals y. So whatever the y value is, that's what the slope is. So I need one where the y values are the same. So that looks like this. And then for a, it's dependent upon the x values. So all the x values are the same. And by that, I'm saying, like, right here, the slope is 0. That looks like maybe it's an x value of -2. So that matches up there. And then x minus y, so where x and y are the same, we'll get 0. So that looks like 15, perhaps. And then x over y, so when x is 0, the whole thing is 0. And then the sign. So when x and y have the same sign, we have negative. And then when x has opposite signs, we have positive. So that looks like 13. That matches up.